Hello, welcome to episode 6C, I think it's 6C. And today we're going to be looking at the center mass of a 3D cone. Okay, so let's think about, let's start right now. Okay, we want to find the center mass position. It's going to be the center mass of the X center mass, Y center mass, and Z center mass. And because this is a 3D cone, there's some symmetry we can take advantage of. That X equals Y equals 0. The center mass for X and Y are the same. They are at 0 point. So we only really need to consider Z. And so what we want to do is we want to find Z. What the hell is that? So we can simplify this integral. So we actually only have to deal with integral of our object z dm over this integral. And so once again, I'm going to do our mass surface density. This time I'm going to use rho. And this is going to be in kilograms over meters cubed. So what is this? Well, we know that dm is going to be equal to this rho times volume, right? This rho times this volume. And so we want to, because it's in 3D, no areas this time. So let's think about getting this volume. Well, we can imagine, if we imagine some tiny slice again, and then, a little higher, we take a bigger slice. Here's our change in Z. And we have this tiny disk. So we want to calculate the volume of this disk. Well, once again, if we zoom in, we're going to have something like this. In blue and purple, and pink is going to be our phi. So what can we do with this? Well, currently nothing, but if you notice, this is similar to our 2D example, right? So we can actually find this area, and this is going to be equal to basically Z tan theta, or Z tan phi. And if you don't know why that's Z tan phi, watch the previous video where we basically have a very similar situation. We find that this length is going to be x tan theta. So this is going to be Z tan phi. Except this is a disk, so this is the radius of our disk, little r. So what is the area of this? So it's going to be area times height, and that's going to give us pi times, so big V is going to be equal to pi times this radius squared, tan phi big squared, times dz. So let's write that again. dm equals rho pi z squared tan squared phi dz. Okay, and we pretty much know enough to start computing these integrals now. We just want to consider the bound. So the bound is going to be from 0 to h. So we want to write this integral. 0 to h of rho pi z cubed tan squared phi dz rho pi z squared tan squared cubed dz. So we can simplify some of these constants. So you disappear. These tan squared terms disappear, and we will end up with our answers here. So this is going to be h cubed over 3 divided, is in our denominator, and on top we are going to have h to the 4 over 4. So what comes out of this is 3 over 4, maybe a different color. What is our final answer? 3 over 4h. Right, and this is going to be our, and this is equal to z. So when we go back here, r equals x, big Y, big Z. This is going to be equal to 0, 0, 3 over 4h. And that is going to be the position vector for the center of mass. All right, so really quick, really simple. There is not much to that one. All right, see you in the next video.